A pleasant day for everyone. I'm John Angel Ohilo, and for today, we are going to discuss the lab exercise number 1 for embedded system, titled Getting Started with ESP32 and WOKWI Simulator. First, you must read and understand the documentation given for lab exercise 1, because here, you will be able to understand what is ESP32 and its parts and buttons. Here you can also see the materials required to execute this lab exercise. You can see this is the materials required. Next one, you can read and understand also the parts of ESP32 or the main part of ESP32, the micro USB port, boot button, EN button, power on LED, input-output pins, and the USB to UART bridge. After you read and understand this lab exercise introduction, we are going to proceed with the lab exercise. Step 1. First, you need to download and install the Arduino IDE software, which you can download at this link. And this is that link. Just choose the Windows or whatever operating system that you are using. And since we are using Windows 10 or Windows 11, this is what I'm going to choose. Then after that, just click this program and run it inside your computer and click install. Next part, open the Arduino IDE and go to the settings and paste this URL, which I already did earlier. But first, let's go to preferences, and as you can see, this is the link or the URL that I pasted, and then click OK. Okay. Next, let's go to the board manager. Click the Arduino IDE, go to the tools, check this board manager, and then type ESP32. Here you can install the module for ESP32 by ESP32 system. As you can see, it's already installed. So we are done with that step. Next one, go to the tools and then board and then choose ESP32 dev module. And since we already installed the ESP32 dev module earlier, of course when we go to the board now, you can see the ESP32 is already available. Just click it and done. As you can see, we already chosen the ESP32 dev module. Next step, we are going to ensure and check if the Silicon Labs port is already installed, which you can see is already installed here in our device manager. Next step, let us just copy and paste this program into our IDE. Paste, and it's here now. Let's put a title, Laboratory number 1. After that, just click the Run button or Upload button. Let us upload. As you can see, compiling sketch. And when you saw this white connecting, just click the boot button. Okay, and after that, you can see it's writing. After 100%, it means that the program has successfully uploaded into the ESP32. Next, click the Reset button or EN button. Done. As you can see, the ESP32 is now blinking, which means we have successfully uploaded our program. Thank you for listening on this part of our lab exercise.
So for WOKWI ESP32 online simulator, first open the ESP32 Arduino Core Simulator template page, or you can type them into the address bar of a new tab in your browser. First, add an LED. Adding an LED is an easy task. Just click on the purple plus icon and select LED in the list. Also, add a resistor and connect them all. Connect them all using wires. Just point to the pin and click. After that, write some code. To blink the LED, you don't need much code. We will just define the pin, which will be toggled. Define the pin as output. In the loop function, we will give some delay and toggle the pin status. This will create a blink pattern on the LED. Here's the code. When you finish writing the code, just click the play button to start the simulation. So for lab challenge, we must design and implement ESP32 circuits with 4 toggle switches as input devices in 8 LEDs, 4 green and 4 red colors. A toggle switches can be turned on only once, meaning if switch 1 is turned, the rest of the switches are off.
I'll start with switch 1. When I turn it on, the green LEDs will light up one by one in sequence, then turn off. After that, the red LEDs will follow the same pattern. This will keep repeating as long as the switch is on. Now, let me turn on switch 1. As you can see, the green LEDs turn on one by one, followed by the red LEDs. If I turn the switch off, the LEDs immediately turn off, stopping the sequence. Next, let's move on to switch 2. This switch activates a sequence where pairs of LEDs light up together in a specific order. Now I'll turn on switch 2. You can see that pairs of LEDs light up, following a predefined pattern. The sequence repeats while the switch is on. And if I turn it OFF, the LEDs turn off and the sequence stops. Now let's check switch 3. This switch controls a continuous LED sequence, where the lights turn on one by one, and then turn off in reverse order. I'll turn on switch 3. You can see the LEDs lighting up in sequence from left to right, and then turning off in reverse order. This continues as long as the switch is on. Now if I turn it off, the sequence stops and all LEDs turn off. Finally, we have switch 4. This switch makes alternating groups of LEDs turn on and off in a flashing pattern. Let me turn on switch 4. You can see that one group of LEDs turns on first, then switches to another group. This alternation continues as long as the switch is on. Now I'll turn it OFF. The LEDs turn off and the pattern stops.